Hi, everyone. Thanks for making it to this very intimate session. I usually present on topics which are a bit ahead of the curve, so only a few people are, ahead of the curve themselves to join this type of session. So congratulations, you're definitely in the category of innovators. Okay, so this session on the Internet of Agents, there is a WebEx room. You're probably familiar with it. So I said hi on the room. So if you want to continue the discussion, use the room even after this session in the coming days, I'll be around and I can take questions and I'll be happy to exchange with you. If not immediately at the end of the session, later on WebEx. I usually talk too much, but I'll try to stay within the hour. I'll actually try to finish a bit earlier so that we have time for, impromptu questions. And yeah, let's do it. Okay, so my name is Guillaume de Saint-Marc. I'm the VP of Engineering for an organization at Cisco called Outshift. Who has been hearing about Outshift already? Great, some of you. Yeah, so Outshift is, as explained here, we're the incubation team, internal incubation team at Cisco. And beyond what's written here, basically, another way, in other words, beyond this great mission statement, which is here, we're a bit like a very special business unit, and we're equipped to actually project ourselves ahead of the curve and enter very ambiguous, non-mature, barely emerging spaces. And you can think about Outshift as really helping Cisco managing risks and opportunities on the non-mature, ambiguous fronts, where the tech is not proven there, yet, where the products are not shaped yet, although we have a product team trying to shape these products. But that's the whole point, right? We are, if you think about, say, Cisco and all the business units as mainstream army, we're more like the special forces projected, ahead of time, trying to understand. And sometimes, we're like, oh, this technology looks really hype, and we're looking at it, and then we're reporting back like, yeah, not for Cisco, not for us. There's nothing there, or there is something, but not for us. Or sometimes there is something, and this is key for the future of Cisco, and we are going to double down, we are going to open the way, and then at some point, our work will graduate in the larger organization. So one of these topics is exactly the Internet of Agents. We started to work on this really, a year and a half ago at the beginning of 2024. And I'm going to present you roughly 6 months of intense work, preceded by a year of forming the thesis and having this in our radar and really starting to realize how important it's going to be for Cisco, for our customers, for our partners, and for the ecosystem. Okay, so that's the agenda for today. I'll go through this. Bear with me. Hopefully you'll like the narrative. There's going to be a proper conclusion, wrap-up with all the key links and stuff you guys can go and look at if you're interested. And yeah, starting with a new computing era. So a paradigm shift is in computing is underway. Do you guys have any idea what this paradigm shift is about? It's pretty fundamental, right? I don't know for you. I've been doing, computer science since I was a kid, and we've been doing this pretty much the same way. And there is something major happening. It's actually a milestone, not just in the industry, at the scale of, I don't know, don't want to be too emphatic, but the history of mankind. Something is changing. What do you guys think it is?
Generative AI.
Yeah, Gen AI. And actually, one of the byproduct of Gen AI, which is very important, which are agents and agentic, right? And so if you think about it, the thing which is fundamentally changing is we've been doing mostly deterministic programming for the past, I don't know how many years, like 60 years, 70 years. And we are going to Agentic, and Agentic through Gen AI, through LLMs, is introducing a dose of probabilistic behavior in the way we can create application, write software to solve solutions. And this is quite profound because it's really going to open new possibilities. And there is a bit of a catchphrase, which I'm sharing immediately. Everyone is familiar with SaaS, software as a service. So with this transformation which is happening, we think that we'll also be able to do service as a software. So not just software as a service, but basically stuff which was absolutely doable only by a human. Some of this, not everything, but some of this increasingly is going to be able to be performed in a reliable way by software. And that's actually quite profound because it means that if you look at the TAM of software and the TAM, the TAM is total addressable market. So if you look at the value of the economy of software versus the economy of service, the economy of service is much larger. So you're probably familiar with this sentence, software is eating the world. So now software is just about to eat an even bigger portion of the world. And this is pretty consequential for a lot of things which are going to happen in the next few months and years. And things are going pretty fast, as you'll see. So where did it all start? So we've talked about generative AI. And so we've all been through this ChatGPT moment. Who remembers the ChatGPT moment? When was it?
November
22. Exactly, sir. November 22, so ChatGPT moment. And everyone's like, ooh, a program is capable of writing poems and interfacing with knowledge management in an incredible way. And this thing is like talking natural language, and it's getting difficult to know that it was not written by a person. And this is just to talk about text and natural language. Of course, these models are multimodal, and with the diffusion model and others, it can also handle and generate imageries, videos, photos. And this is pretty amazing. Actually, you can generate anything. You can even generate molecules, proteins, in different fields. So there is no limit to how far generative AI is going. And so everyone saw that, and everyone got excited, and this was the beginning of this generative AI and now agentic era, which we are not close to get out of. It's just starting. But something else happened. And this second thing came a few months later, and this one, I think most people did not realize how important it was and how profound it was. Actually, there is a company which made everyone realize how important it was, which is a Chinese company called DeepSeek. So what is this other thing which happened, which, by the way, the likes of OpenAI and Anthropic and others were there first, but it got less attention from the world. So this second thing is the ability, and this is really a discovery. Like, everyone knew that these LLMs were really good for generating, content. But what we discovered a bit later down the road is that these LLMs are also capable of reasoning. And that is as important as the first point, if not more important. The two are equally important, let's put it this way. And the reasoning, the idea of the reasoning is fairly simple. Instead of taking a large language model and asking it, you have a question or you have a prompt, and you're asking it, in one hop, in one cycle, in one inference, just to output magically the best possible answer. Instead of doing this, it's a very simple principle. For those who like philosophy and mathematics, you can go back to Descartes, the well-known French philosopher and mathematician who wrote about solving any problem by cutting the problem into smaller problems until each problem is relatively easy to solve. Solve each problem, reassemble, and voila, you have solved the bigger problem. This is exactly how reasoning is working with LLMs, right? So large language models, if you tell them, hey, don't try to answer in one hop. Take your time. Think about the question I just asked. And start to plan about it. What would be the different, how would you decompose it? What would be your plan to decompose the question? And then iteratively, through different inference cycle, you break it down into smaller, more easier question in a way, or more narrowly focused question. And at some point, the LLM is doing a pretty good job at answering each of the individual questions. Even if the model is a smaller model, at the beginning of, shortly after the ChatGPT moment, everyone was excited about, oh, let's go and build super big models, right? And this was this race to, we're getting to 20 billion parameters, and then 100 billion parameters, and then 500 billion, even now beyond the thousands of billions of parameters in the latest version of Llama or OpenAI. And this is brute force. This is just trying to have a model which is capable of doing as much as possible in one inference. But then a smaller company, a different company, and this is what DeepSeek showed, is that with a smaller model, but which you use iteratively, and you give it, like you have 100 inference, you can go through this 100 times, decompose, and even a much smaller model could actually, in the benchmark, in the leaderboard, start to score as much bigger models. And this is the power of reasoning.
Can I ask a question?
Yeah, sure.
So the reasoning, the next token itself is a part of the reasoning cycle, or is there any reasoning engine?
It's actually more like a reasoning engine, right? So it's more like you feed the model iteratively with its own answer. And the reasoning is happening in natural language. So the model is literally...
Naturally, so there's no reasoning logic. The next token prediction itself is
iteratively... Exactly. Right. And this is where you realize that natural language is important to generate, content, But it's also... this is pretty deep, but you cannot reason without thinking in your head about what, like you need to, if you don't know how to speak, you can barely reason, right? So you need language to be able to reason, and that's what these things are doing pretty well. Anyway, so let me accelerate. But so with this ability to generate and this ability to reason, we are now capable of solving more complex problems, goal-oriented, and this is when we start to get into this agentic world. So what is the definition of an agent? By the way, agents are really important because we think that this is how really the value of generative AI is going to crystallize for most organizations and enterprises, right? It's going to be through agents. It's a nice, well-rounded unit of capability, which we think is going to be, I don't want to make this comparison too much, but similar to, for the cloud-native stack, which you're probably familiar with, everything is now a container and a microservice. So the way to think about how GenAI is going to crystallize is through these agents, right? Which we can compose and combine. We'll talk about it. Okay, so what is an agent? Good question. So two definitions, not from me, from two third parties. The first one from OpenAI. Well, agents are systems that independently accomplish tasks on your behalf. That's a pretty short and pretty deep and pretty cool definition. It falls short of some consideration, but that's basically these things are becoming smarter, autonomous, and instead of coming back to me every 5 seconds, I can give them a mission, a goal. They deal with it for a minute, 10 minutes, 2 days, whatever. They come back, and they should have, accomplished what I need. The one from Anthropic, another important AI lab, is a bit more verbose, but interesting as well. The gist of it is that they say that agents are basically capable of operating independently and using tools to accomplish a task. And they make the difference between agents which are going to follow a well-defined, pre-established workflow versus the agents which are going to almost like completely autonomously reason and find their way through the task you're asking them to do. There is no right, wrong. The thing which I would take away from this, and this is a good one from Andrew Ng, who's someone who has been talking a lot about agents since last year. So Andrew is saying that all these definitions are good, and there are different levels of like the agentic nature of a solution can go from it's a little bit agentic to it's a lot agentic, right? And we have to deal with this continuum. So how do you build an agent? That's super high level because I'm not going to talk too much about agents. I'm going to talk about how you make agents work together. But in in one slide here, to build an agent, so you need a few ingredients. So you need at least one LLM, because that's typically how you do the reasoning and how you do interesting stuff. You can have more than one LLM. It's often that in an agent, for cost optimization, efficiency reason, you can use more than one. Like, for instance, you have an LLM specializing on the reasoning, which is usually a fairly big and quite smart LLM in a way. And you can have smaller, cheaper LLMs, for instance, specializing on function callings, that is, choosing the right tool for the right task at a point in time, just as an example. You need memory because an agent needs to retain information at least for the duration of a session, not forget everything each time it's inferring. Access to tools and functions, because if you don't have access to tools and functions, then your agent has no agency, and this is limiting. Data retrieval, identity and access management, because otherwise your agent is just wandering and doing things which might not be permitted. And there's different ways to actually organize this capability, and so there are different frameworks or different architectures for building an agent. And I've just listed a few. Line of thoughts, that's the classic one. I'm going to do A, B, C, D, and then you go through this. But sometimes it's a more complex call graph workflow which you're going through, and sometimes it's more like a swarm of agents. You just throw agents into, literally, figuratively speaking, you take agents, you throw them in a room where they can collaborate, and you see if they can address your task. So there's different, there are frameworks like React, which have been well documented and super interesting stuff. Anyway, there are many ways to build agents. So that's it. That's what's inside an agent, okay? And so the problem that we have been at Outshift particularly interested, so of course we are very interested at Cisco and Outshift about building agents. If you have heard about our announcements today, it's a lot about agents. Why? Because agents, as I said, service as a software, this applies to IT. So there's a lot of AI ops, NetOps, DevOps, all types of operations which we can automate and which we can autonomously consider with a bunch of agents, and this will increase in the future. But the problem that beyond agents, the problem that we looked at from the beginning is the following. The minute you have an agent, the second after, you want to connect it with another agent. Just like the minute you hire someone in your company, the second after, you want this person to work with the rest of the company, right? Because if you just hire someone who stays, in its bubble, well, the person can do stuff, but it's not as interesting as if the person can collaborate. So it's the same with agents. If you think about agents as being fairly specialized, they will be very good at doing some stuff, but then you want them to collaborate with other agents in order to achieve, higher order tasks, workflows, and mission across your organization. So that's exactly what we've been obsessed about. Because we saw agents coming a year and a half ago, and we're like, okay, these agents, they will need to work together, but there are a few issues. These agents are coming from different vendors. Yes, because of course, an organization can build its own agents and will certainly build agents for its core business. I don't know, if you're a large financial institution, you're going to probably build, your agents which are, specific to your differentiation and your capabilities in your industry. But there's a ton of agents which you just want to source from vendors. If you want the best, sales agent, maybe you'll take the one from Salesforce. If you want the best Workday agent for your HR, HR agent, maybe you'll take it from Workday. By the way, interestingly, all these companies, as you've seen, started to communicate on their agents. So a lot of large SaaS players are starting to offer you to consume their service through an agent. No surprise to us. We saw that coming. We're already on the next problem. Then how do we connect these agents together? So different vendors, they will be using different development frameworks, running across different clouds, have different access controls, different tools, belong to different organizations, and they can act on behalf of different person or different personas. And then when we saw that, and when we foresee this coming, we're like, this is an interesting problem. And the reflex was, this is going to need, basically, for these agents to collaborate like a team of matter subject experts, we'll need a framework. So let me give you a couple of examples. Example one, you want to deploy an IT infrastructure. Well, different agents will be able to help you to do that in the near future. In this example, you want to deploy the application, look at the business logic, describe the service, generate tickets, do the checking of the deployment on the scale, security checking, look at the cost. All these different tasks can come from specialized agents. And you're already connecting, for instance, agents coming from OpenAI, ServiceNow, Salesforce, Microsoft, Cisco, whatever, right? So it's already immediately when you want to do something interesting, you can foresee how you need to connect agents from different vendors. To take another more extreme topic, example, and getting into what we call embodied AIs. So agents will live in the cloud, but agents will also be embodied. When you're taking a ride on a Waymo today, well, you can consider that there is an agent running in this car somehow, right? And robotics and mechatronics is making incredible progress. And so there will also be physical agents and physical AI. And so if you take the use case of drug discovery, so this is using generative AI to discover new proteins, for instance, or even material science, you can think about how you can connect, again, an agent specializing in the modelization of proteins, another one looking at the cost of producing this, another agent which can be a wet lab, a self-driven lab, literally. So an agent can automate doing some of the experiment in the lab, whether it's for life science or, again, material science. And this is another extreme version of how we want to connect agents across vendors and across domains to achieve high-value tasks. This is not science fiction. All the building blocks exist today, and this is where we are headed. And so the infrastructure, the capability for these agents to be discovered, to be connected, and to collaborate, this is what we call the Internet of Agents. At Cisco, we've been very involved building the Internet and making humans and machines collaborate, and now we want to do the same thing with agents. So one thing I'm sharing here, which is important, is that I talked about agents, and now I'm talking about building multi-agent systems to achieve higher order tasks. So there is a bit of a catch here. Because when you put 3 agents together to do something, the resulting application is an agent itself, just of a higher order. And so if you think about it, and we've been thinking about it a lot, I'm sharing this because you can get lost sometimes like, well, but an agent can be made of multiple agents. Yes, absolutely. So there is a sort of a recursive composability aspect here. So just bear with it. This is the complexity that we have to embrace. And so the Internet of Agents is an open, interoperable internet for quantum safe and agent-to-agent collaboration. So why quantum safe? We're in 2025. We need to be serious about it. Quantum is coming. By the way, this is a topic where our team at Outshift is spending the rest of our time when we are not working on Agentic. So we have to be quantum safe. And why open and interoperable? Well, for a simple reason. If you want to maximize the value for an ecosystem of players and partners and enterprise, grounding this emerging business on an open and interoperable platform, just like we did 30 years ago with the internet, is the best way to maximize the value for everyone. Some players will tell you, no, it's okay, just put everything on our platform, and of course your agents will work and they will be integrated. This is certainly a way to optimize the value for these players, less so for the rest of the ecosystem. So the ambition here, the birthright to play of Cisco in this domain, is to help establish an open and interoperable framework for this Internet of Agents. So quickly, so some people were telling me, hey, GSM, this is nice, but we have a lot of tech already. Yeah, by the way, people are calling me GSM because my name is long and complicated, so GSM is simpler. So people call me GSM at Cisco. So hey, GSM, nice story, but this is a bit bullshit. We don't need all these new consideration. We have the cloud native stack. We can do a lot already. These agents, well, they are workloads. Most of them will run on the cloud. We have everything we need to manage workloads in the cloud. To connect them, the cloud native stack is already composable and all this. Why bother? So, why bother? Because there is a fundamental shift happening in computer science, and this is new. So we've been connecting humans and machines for a long time, but now we are connecting agents. And the difference is that agents have attributes and properties of humans, but at the scale and speed of machines. So the way agents are coming across the stack is like this, right? And it's changing a lot of things. And if you don't acknowledge that they are special entities and that there is a bit of work to welcome them in the stack, you'll be in trouble. And the fundamental things we need is how do we discover and identify these agents? How do we securely connect them for the collaboration I mentioned? And how do we observe and evaluate their behavior? And at this point, no surprise. This is a Cisco event. So you see why we are interested in this domain. You see why the Internet of Agents is so important for Cisco and for the industry, and why we think we want to work with the rest of the ecosystem, and why we want to play here, because it's about connectivity, security, observability, of course. Okay, so I'll go quick. This is the Internet. A lot of cool tech that we are using today. On top of this, the cloud internet emerged, all the cloud native stack. I'm not going there, you're familiar with this. So the thesis here is there is a new layer emerging, the agentic layer. There's no way we are going to reinvent anything from the cloud native stack, but we want to make sure that we acknowledge that we need a new layer on top. And so for those familiar with the well-known OZ model, we are even considering that there are some new levels which are emerging on top, which are worth paying attention to. And yes, of course, it's all application level. It's all layer 7, what I'm going to talk about. But the syntactic and the semantic aspect of the agent communication can literally be considered as 2 new layers which are worth looking at specifically. So let me tell you a bit more about this. So that's the architecture of what we call the Internet of Agents. And we are going through 3 levels. At the top, we have something called an agent directory. And this is the ability to, if you want to think about it, that's like a little bit like the DNS for agents, except that we are 30 years later, so we've designed it in a bit more modern way. This entire architecture is distributed, no surprise, to scale, but also decentralized. So there is no central authority administrating this. This is very important for us. So there is a directory in which you put agent cards, agent records. Anyone can announce, anyone can discover, everybody should be able to search. That's the problem we are solving with the directory. Then you need to be able to connect agents because you want to compose what we call multi-agent systems, multi-agent software. And then you want to be able to deploy, and you want to be able to observe how these things are and evaluate how good these agents are working together. Just like when you create a team, sports, business, enterprise, when you create a team of people, you need to evaluate how well they are doing, right? Same with agents. That's the same view, but this is more like a stack view. Again, identity, directory. The 3 layers I mentioned, the messaging layer, this is classic networking. Syntactic and semantic layers, where there is new stuff happening, especially around natural language. And then another 3 pillars with the agent workflow server, which is a way to deploy these agents, the security, and the observability/evaluation part of the stack. Okay, so you might think, this is nice, this is theoretical. It's actually getting a bit more practical. So back in February, together with Langchain and Galileo, the 3 initial founders, it was just the 3 of us at the time. In February, just 3 of us, 3 players. We announced agency. I said it's very important for Cisco to make it like open and interoperable in order to maximize the value for the ecosystem. So we've been working, and we've been open sourcing Agency, which is exactly this foundation for all this tech to be open sourced, so that anyone can build products and compete on top of this stack, just like what we did a while ago with the internet. So it's an open source collective, and you see that in what? So we announced at the end of Feb or early March. We did the first code drop, I think, at the end of March. So it's been 2 months plus, 3 months, 2.5. We've onboarded, 50 partners plus. Mostly startups, agentic startups, who get it, right? Because they understand the amount of potential there is in this direction, and they are excited. Okay, so let me tell you a little bit more about these different technologies we've open sourced. So the first one is called OASF. Who's familiar with OCSF in the room? Great. So OCSF is a great schema framework to describe any type of cybersecurity attack. And actually, we looked at it, and Giovanna, who's sitting at the back of the room, looked at it, and she said, well, actually, this framework is really good, and we can use something similar to describe any agent. And so we've literally copy-paste branched OCSF, and we rebooted it under OASF, Open Agentic Schema Framework. And it's extendable. You can describe any agent object, any agent skills, any agent domains. And we welcome contribution to make this schema description of the world of agent bigger and more accurate. So you might think, well, we don't care too much about a schema GSM because what we need with agents is just like a piece of natural language text describing what these agents are doing, and that's all we need, because then we can go agentic and we can feed this to an LLM and it will figure out whether this particular agent is good for the task it's trying to do. Yes, that's true. But in addition, there's a lot of infrastructure through the discovery, the observability, the security, and having a sort of a deterministic. We're not going for only probabilistic. We need the blend, right? So there's a lot of probabilistic, but having a dose of deterministic to actually bring some reliability to this system is very important. So that's what OASF is doing. And I put the link to the portal where you can check out OASF. It's part of Agency. Then we have a directory. I pretty much described it already. The directory is decentralized. In this case, it's OCI-based, just like containers. Told you, there's inspiration of how containers work and how agent can work, but extended to actually host the agent cards, agent records from different organizations. And the beauty of the agent directory is the following. I said it's decentralized. It is. So the agent directory is, you can think about it as a node, which can hold for, I don't know, Adobe, Cisco, Microsoft, all these organizations will have agents. So they can host their directory, and they can serve, the different agent description to whoever wants to use their agents. But then this directory can sync with each other in order to cross-populate based on the trust between these organizations. And so any agent which is flagged public, like for instance in the Cisco directory, can flow to, I don't know, the Adobe or the Salesforce or the Microsoft or the Workday or whichever other organization. And that's how we start to underpin and deploy a planet-scale directory to discover, publish, announce, and retrieve information about agents. That's pretty cool. And of course, everything is cryptographically secure, so you can authentify, you can make sure that authentication, authorization, about what all the data which is in the directory is sound and good. We thought it would be useful to offer a free SaaS version of it so that you don't have to deploy and download the open source and run it by yourself. We've put an initial UI on top of this, and then you can discover agents, you can search, you can do it. So if you guys want to experiment with it, you can use the free service that we launched. It's, again, hosted under Agency. And yeah, it's a good way to, if you want to go production grade and if you want to start being serious about running a directory for your organization, you want to run your own, right? But to get started, this is a great way. This is how we do a lot of hackathon at the moment. around this with the community. And of course, we have agent identity. So we just actually dropped the code last week, I think. So not only we have directory, but we have nodes which can hold the keys to all the identity of these agents. And it's a very important component because, as I said, agents have attributes of humans, where most of the IAM systems are based on, but at the scale and speed of machines. So the identity, the scalability you need for identity, the speed at which we can rotate credentials. Well, first provision credentials, rotate, remove credentials for agents is much higher scale than anything we've done so far with identities, right? And so we are provisioning for this. And we support all type of, by the way, we have a Cisco Duo integration now that Duo is an identity provider. Of course, we didn't miss this one, but also supporting, Okta, Auth0, Active Directory. And we can also use any decentralized identifiers like DIDs. So that's a pretty cool component as well. And there is much more coming on this because we are looking into how we can make sure that these agents are using their agency in a very controlled way so that if you give the permission to an agent to do a sensitive operation, you don't want them to retain, the tokens for doing something else unsupervised next time. So there's a lot of cool stuff that we're going to do here. We're actually working with a bunch of partners here, Permit.io, Skyfire, if I remember well, and a few others. We have a working group. Like behind each of these topics, we have a multiplayer working group in the agency open source project. Okay, I'm late already. I need to speed up. So securely compose and connect. So let me go quickly through this one. So we have open source a technology which is super cool, which is called SLIM. We called it Agent Gateway Protocol, but this was boring, so we came up with SLIM, which is a bit more fun. Secure, low latency, interactive messaging. It's actually, you can think about SLIM. Remember, I said we need to connect these agents across clouds, across different organizations. Some will be on-prem, some will be at my edge, some will be running in the cloud. So SLIM is, you can think about SLIM as a sort of all roads overlay network, a way to connect these agents anywhere they are, over the top almost in a way, bind the identities, and use this for any type of agent-to-agent communication. One-to-one, fire and forget, peer-to-peer, group-based communication. And there is MLS, which is a fairly complex, but all the complexity is taken care of for you here. So MLS is the latest and greatest way to secure group-based communication in the industry, so that you have the guarantee that agents will only be able to intercept information which, for the groups they are part of, right? And you can revoke agents if they are not allowed anymore to be part of a certain discussion, multi-agent discussion or collaboration. You can do all this. So SLIM is a very cool technology, and it supports MCP and A2A. I'll come back to this in a second. So these are the components that we've released for composition. There's a few more, but so SLIM, as I said, ACP. So ACP, Agent Connect Protocol, you have all the details on the Git. So we did this one with LangChain together. So LangChain had something called Agent Protocol, which is very popular. So we've done something very close to this with a few additional capabilities called ACP. And it ties with the workflow server if you want to deploy. And the nice thing with the workflow server is like if you have, let's say, a LangGraph agent and a Llama index agent, they will be able to talk to each other at the syntactic level automatically with the stuff we've open sourced. And of course, now we are calling the community to help and build all these connectors, right? Because there's a lot of work, but we think this is a good start. And of course, over the past few months, MCP and A2A have emerged. Who's familiar with MCP and A2A in the room? Heard yeah, cool. So MCP from Anthropic, this is a way to connect an agent to tools or to connect an agent to data sources. They started to hit the radar of the world back in January, and there's a stellar growth and adoption. So we're very happy to support MCP. It's good, right? Sometimes people are trying to use MCP for agent-to-agent collaboration. We're like, it's better for agent tools and agent to data, right? And for agent to agent, something like A2A from Google, which was announced after agency, or ACP are good. And we have something on top called the IO mapper. So say you have two agents which are perfectly capable of communicating with each other, but one is, I don't know, for instance, talking, this is a problem I know, Fahrenheit degrees, and the other one is talking Celsius degrees. There might be some quid pro quo. So the IO mapper is a pure semantic level component, which is going to help bridge, two agents to understand each other better in the plane of natural language. So this is the kind of tech that we found would be useful. And as always, with an open source project, we have an example. We have a bunch of sample applications, but we have one called Accorda, which I'll show you a demo in a few minutes, which is also available on the DevNet booth. And Accorda is just a good way to start with a simple application using a lot of these components. And our ambition for those familiar with the sock shop, the Kubernetes sock shop, is to do something a bit similar for Agentic here. No, you use one or the other. So the question is, does A2A and ACP, so they are the same level, so you don't need to use both. You use one or the other, but all of that can be carried through over Slim that I presented. And so I'll go quickly on this one, but the way to think about building with this toolkit an agentic solution is you establish a Slim messaging bus, you connect your agents, you connect your tools, and from there, you're ready to compose the collaboration between agents. Note that this is giving you N plus P integration, not N by P integration. So the fact that you can use Slim as a messaging bus, if you want, for all your agentic composition is saving a lot of efforts already. So then you build the graph of collaboration, right? It can be an arbitrarily complex way for agents to, you can have a fixed workflow call graph, which is already certified, which you want to reuse and just pick agents to do certain tasks. Or you can throw agents in a room and say, figure it out. This is the mission for you guys. And, they are supposed to figure it out. So two very extreme types of composition I just mentioned. And again, it's a spectrum, right? From prefixed workflows to completely on-the-fly agentic collaboration emerging from the different attributes of these agents. And here I've been zooming a little bit on one agent. Also something to keep in mind is the agents, like the green part here is the multi-app software itself, which probably is going to run in the environment of the enterprise. But the agents themselves, most of the time, they will be hosted somewhere else, outside. So again, wrap your head around this. The agents might be running in the cloud. Here, we are really looking at just the call graph of how these agents are working together. That's the tech we are powering here. And of course, we have observability built in everywhere, so we can take telemetry. So we are extending open telemetry for this. Telemetry from the Slim messaging layer, telemetry from the agent itself. We have SDKs for this telemetry from MCP, A2A. All this we can instrument to extract telemetry and to understand how to monitor how the multi-agent system is working. We had our first code drop on, when was it, Giovanna? Today. Okay, that's amazing. First code drop on our observability SDK today. So things are going fast. And of course, all this is open. We're working with Galileo on this and a few others. There is also a very active working group, but we are Cisco, so you can guess that we are going to do some work with Splunk on this as well.
Is that how Cisco will work with partners, making Cisco agents and data available using this technical framework?
Yeah. I know we are announcing AI Canvas today. The ambition of this team is to leverage this directory because we don't want Canvas, for instance, to be just a Cisco-only, walled garden boutique thing. We want to be able to welcome agents from third parties in there. So absolutely. At least this is what we are encouraging the rest of our colleagues at Cisco, is to embrace an architecture like this, because we think it's a really good foundation. So keep this in mind. Agency, we love all protocols, not just the one we've created. We like the one from Google's, from Anthropic, and from other players. We are not a protocol. We are an entire architecture. We'll just go with whatever works, whatever is convenient for you guys and for the industry. OK, Observability, one quick slide. Giovanna, you won't be happy because I'm not going to make justice to it, but that's basically how we can instrument the different agents and how we can, throw the telemetry into a database. And so today we've open sourced the SDK. We are going to open source also a bit more in the coming weeks. The end-to-end module is interesting because that's the way to reconstruct all the interaction between agents. Sometimes your agents are working through, as I said, well predefined workflows. So theoretically, you know exactly which agent is talking to which agent to do what. Sometimes you're throwing a bunch of agents in the same room, and they have to figure it out. So what interaction is going to happen? You don't know. And you need, this is where, again, this is very different from a cloud-native application, because there is a dose of probabilistic behavior. So this time, if you don't have observability, basically you have no idea what these agents are doing behind these closed doors, which is a problem. So we'll also publish a bunch of metrics. So with observability, we can do cool things like precisely, what does this topology look like? Is the topology stable? Does it change a lot, or is it always the same agents talking to the same agent? What is the error rate of using a tool, or do we have a lot of format issues between agents, which are creating issues, which we can fix? So all this will be interesting to see. And beyond that, evaluation is also important. So if you think about a team of agents, are they playing well together? Same for soccer teams. If you want them to be good in the championship, the players need to play well together. Same with agents. And if something is not going well, you might want to swap an agent for another one. But you need to have more information and better understanding of how this agentic system is behaving and which agents are the most important, maybe responsible for the quality of the final outcome of your application. So this is cool because this is all the stuff we know, just reimagined in a layer above. At least to me, it's exciting. OK, so mass examples. So this is Accorda, the simple demo example application made to learn and to understand how it works. So it's the story is that it's a fictional coffee agency. And I'll show you in a minute the Corto and the longer demo, which is here, actually. So here is the agent directory. So we are going to search for coffee. And we'll see the bunch of agents which we are using for this agency coffee. And you'll see that in a second. And so once we've selected these agents, so coffee, OK, I have 5 agents. One is the buyer agent. So that's basically the agent which is trying to buy coffee. You have 3 other agents, Colombia, Brazil, Vietnam, 3 farms. They have an agent which is capable of responding to logistic and buyer requests, depending on the productivity of the site. And we also have a sommelier agent which is capable of talking in nice words about the quality of the coffee. So that's basically the, how you see and discover all these agents in the directory. You can click on an agent. You'll have general information about the agent. You can download the OASF JSON model associated to this agent. Anyway, cool stuff. So now we find the agents. We know which agents we want to use for our application. So we'll start with this is literally a hello world. You can't get to a simpler application. This is what we call Corto. We have only 2 agents. The buyer agent will talk to the sommelier, actually, and asking to describe Ethiopian coffees in the spring, right? And the sommelier agent will answer. So this is a very simple application, but a good opportunity when you look at the code to see how you set up 2 agents, how you register them with Slim, and how you make them talk, in this case, with A2A. So even if it's literally a hello world, but looking at the code is really cool to get started. We have a slightly more interesting example, which is this one that we call Longo. So here we have 4 agents, a slim bus for the messaging, and 1 MCP server for the tools. In this case, it's a weather station type of agent, which is giving additional information to the Colombia farm about the state of weather, the prediction, and then the state of the production. And then the buyer agent is starting to ask questions, and you see each time it's activating, and it's contacting all 3 agents to get, their response, and then figuring out, what's the next action. So again, a very simple example, but a little bit more complex, where you see this is exactly what I said: connect agents and tools through 1 messaging bus, and from there you can focus on the composition because everything is working, below in the stack. So if you want a full demo, go and check it on the DevNet zone. There's a couple of guys, you'll see them in a second, which they can help you with this. So a bit more advanced examples of multi-agent systems. Jarvis is a cool one. So I'm the VP of engineering of Outshift. So in my team, I have engineers, mostly developers, but also a platform team. And Asit, who's leading the platform team for my organization, based in UK, he always come to me, suddenly you'll smile, oh, GSM, there is so much work, we have all these projects, all these Outshift stuff, I need more people. And I'm like, I'm sorry, Asit, I can't, we're at capacity, we're consuming all our budget. So if you want more people, why don't you think about onboarding agents in your team? And so it started a bit as a joke, but this is something which we've done actually pretty seriously. And this is amazing. So we've started to create different agents for our own SRE DevOps organization, right? The team supporting the rest of my different project teams. And we looked at a lot of relatively simple yet non-trivial tasks like, hey, can you provision a cluster? Can you deploy on AWS? Can you help me with all sorts of tasks? I need to open, I need new credential on AWS for this project, all this stuff. And so a few months later, so of course this is leveraging agency, all the tech you've seen before. And so, yeah, so we've connected, more than 50 tools, from Kubernetes to PagerDuty to Backstage to, Jira. We have different user interface. So the humans in my team can interface with Jarvis Agentic system through WebEx, Backstage, different tools. And we have more than 10 workflows which are entirely agentified. And the net is that we have freed up 3 people who can do much more interesting stuff, not just sit behind the help desk for the rest of the team. And these guys, what are they doing? They are developing more Jarvis feature, which is much more interesting for them. So this is and by the way, we've open sourced a good part of it. So you can check this. It's not open source on agency because actually, of course, it's leveraging agency, but it's open source as part of another initiative called Canoe, which is a gathering of platform folks across the industry with AWS, Adobe, Salesforce, and a few others there. So that's interesting. And a very, very concrete proof point of the, you look at the metrics, you're like, Agentic can help, right? And this is not a demo. This is what we use every day in my team to work. So more sessions are coming. So I'm starting with John and Cody at the top. So the partner in crimes on agency. So these guys are at the DevNet zone. And if you want to go deeper in the demo, you can go and check what they have. Frank, who's a distinguished engineer in my team, is going to present tomorrow at 10:30 about another super interesting agentic application for troubleshooting. So I told you at the beginning that agents are going to revolutionize AI ops. So that's the proof, right? And it's always very complex when you have a large system, many layers in the stack to know where the problem is coming from. Like the voting application, the voting module of my application stopped working, where is it? Is it a server problem, a software upload, a version problem, a network problem? There are so many potential root causes. And Frank will show you what we've done here. It's pretty amazing. And last but not least, Giovanna, who's here, has a session on Thursday about another super interesting work we are doing around agentic AI and net DevOps, and in particular, how we can validate very large network configuration changes at the scale of a service provider. So not a small network scale, entirely assisted with agents. And that's also give you a good vision of what's just about to happen in this industry. And with that, I think that I'm almost done. This is a summary. A shift is happening. Let's embrace multi-agent software. Agency.org is there. This is cool. If you want to contribute, you're welcome. If you want to talk to us, talk to us. If you want to use it, go and check the Git, and you can use it. And of course, Cisco is active here. It's framework agnostic and vendor neutral. There is no catch. Go and use it. You can work with anyone you want, not just Cisco on this. And of course, Cisco will keep investing here, and we will obviously, in the near future, you can expect more and more of this roadmap to infuse across Cisco's product and enterprise-grade product that we are announcing, at each Cisco Live. Want to learn more? I've put a bunch of links. Ping me on the WebEx room if needed. Otherwise, this will be in the recording. Link to agency if you want to join one of the working group. All the working group are pretty active at this point. How to get involved? You can adopt, you can support, you can join a working group. As just said, you can contribute. All this is good. And that's it. So please take a minute to evaluate this session. I hope it was interesting. I am almost on time. We have 2 minutes left. If there is any question in the room, I'm happy to take it now. Otherwise, contact me here, ping me on LinkedIn, ping me in the room. I'm available. Thank you very much. Any question? We're good? Okay. Yes, you.
Previous slides.
Oh, the previous slide, sorry. Yes, you want my email. My email is here. Yeah, the slides, the PDF will be available. The video recording will be on YouTube in the next few days, so you can. And I have another session tomorrow if you're interested. Not on the Internet of Agents, but more specifically on how to connect data and LLMs in the context of enterprise, which is another big problem that we are looking into, which of course is a building block of this bigger picture, but I'm focusing on specifically how to connect data and LLMs to build agents, basically. That's pretty cool.
Data in like SQL?
All data. So the problem space of my session tomorrow is really like your AI project and Gen AI project and Agentic project will not take off until you have connected your enterprise data to this. But you can't do it.
Not through the RAG, through some
RAG is one of the 5 methods we'll go through tomorrow.
Okay, thank you.
Yeah.
Can you go to the previous slide?
I can? Sure. This one or?
Not the GitHub URLs. Yeah, that one.
No worries. Thank you very much.
Thank you.